Afternoon, everyone. So today we are going to see some of the questions based on the week fifth of the course Introduction to Robotics, which has been taught on the NPTEL portal by the professor. So today we are going to study or solve some of the questions based on the lectures taken in the week fourth and week fifth of this course Introduction to Robotics. So we'll take a first few questions from the last week, like some of the week fourth question, like three or four questions we'll solve. Then we'll move on to the questions on the week fifth. So this video will be recorded and will be uploaded on YouTube. So if anyone missing this lecture here, can also watch on YouTube. Uh, the link will be provided in the NPTEL portal. So we'll start with the first questions. Like here you can see that. The SCADA manipulator joints are given and all the axes are defined. And in this, the position Px, Py, and Pz is also given. Like here, the position Px that is given as A1 cos theta 1 plus A2 cos theta 1 minus theta 2. Py is given as A1 sin theta 1 plus A2 sin of theta 1 minus theta 2, and Pz is given d1 minus d3 minus d4. So this is a scalar robot, and so the scalar robot have rotational joint, two rotational joint, then one prismatic joint, and then again one rotational joint. So this rotational joint, first one is theta 1, second one is theta 2, third one is the d3, fourth one is the theta 4. So these are the variable. Like in rotational joint, the variable is theta 1. In the second rotational joint, the variable is theta 2. And in the third joint, that is prismatic, the variable is d3. And in the fourth joint, the variable is theta 4. So we have to find the Jacobian J. So Jacobian J is equal to del of px by del of theta 1, del of px by del of theta 2. And then the variable in the third term is d3. So del of d3, then del of px by theta 4. So like this only, we have to write for all the rows. The second one is del py by del theta 1, del py by del of theta 2, del of py by del of d3, del of py by del of theta 4. And the third one is del of pz by del of theta 1, del of d3, and del of pz by del of theta 4. So now we will find this del px by del theta 1. So here we will get, so it will become a1 of, so the differentiation of cos theta 1 will become sin theta 1, and it is negative sign will come, plus a2 of cos theta 1 minus theta 2. So it will become a2 of, we can write this as, first we will expand this. So when you expand this, or we can directly differentiate also. So let's suppose del this will become minus of a2 of sine of theta 1 minus theta 2. Okay. So this term we can write as a minus a1 of s1 minus a2 of s of 1 minus 2. So from this above option, we can see that I guess all these options have this in the first term, like in the first row and first column, this term is there. So we have to do again del px by del theta 2. So in this, when you differentiate with respect to theta 2, it will become first term will become 0 minus of a2 of sine theta 1 minus theta 2 into of minus 1, because here the sine of theta 2 is minus and it is differentiated with respect to theta 2. So this will become a2 sine theta 1 minus theta 2. So from this you can see that option B and option D is the correct till now. Now we will do del of px by del of dd3 is equal to 0, and del of px by del of theta 4 is equal to 0. Now del of py by del of theta 1. So our py is a1 sine theta 1 plus a2 of sine of theta 1 minus theta 2. We have to differentiate this by del of theta 1, that is equal to a1 cos theta 1 plus a2 sin theta 1 minus theta 2. So this we can write as a1 c1 plus a2 s of 1 minus 2. Again, when you differentiate del py by del theta 2 is equal to 0 plus a2 of cos theta 1 minus theta 2, minus sign will come, so it will become minus a2 c of 1 minus 2. And when you do del py by del d3 is equal to 0, and del py by del theta 4 is also equal to 0. After that, when our pz is equal to d1 minus d3 minus d4, so del of pz by del of theta 1 is equal to 0. This is also 0, and this will become minus 1. This will become also 0. So now our Jacobian function, that can be written as minus a1 s1 minus a2 s1 minus 2. The second term is a2 s1 minus 2. These two terms are 0. After that, it will become a1 c1 plus a2 c a1 c1 plus a2 s of 1 minus 2. Then second term minus a2 c of 1 minus 2. Then this two term will become 0. And in the third row, it will become 0, 0, minus 1, 0. So the correct option is option B. Actually, it is matching. So one option is not matching. Minus a2 of c1 minus 2. Here we have got minus, it is plus. No, it's minus only. a1 c1 plus a2 s1 minus 2. So So here is sine, so the differentiation will become here cos. Okay, so it will become C of 1 minus 2. So the correct option for this question is the option B. If you have any doubt, then you can ask. And if you are watching in YouTube, then you can also comment in the comment section of the YouTube. There we can reply. So we'll move on to the next question. So the dexterity of this robotic manipulator is given as A1, A2 of S2. So in this it is asking at what angle theta 2 manipulator will show boundary similarity. For boundary similarity, the arm should be fully stretched. So this sine theta should be 0. So here you will get theta like sine of theta 2 is equal to 0. So theta 2 will become sine theta 2 will become 0. Theta 2 is either equal to 0 or equal to pi or multiple of pi. So the option A is correct. So we'll move on to the next question. This was also from the week 4th. Which of the following are the sufficiency condition for the existence of a closed loop solution? For closed loop solution, we have already studied either the three adjacent joint axes should be intersecting or three adjacent joint axes parallel to one another. So option A and option D are correct. Now we will see one more question, like how to find the pseudo inverse. So pseudo inverse is found when the matrix is of not of the square size. Here you can see the matrix of 2 cross 3. So the pseudo inverse B plus is represented as B of transpose B of B transpose whole inverse. So here you can see B is of 2 cross 3. So 2 cross 3 into 3 cross 2 will become 2 cross 2. So the inverse of this term will exist. So here we have to write. First we'll find B of B transpose. So B is equal to 1 1 0 minus 1 3 0 and B transpose is 1 1 0 minus 1 3 0. So when you multiply this, you will get 10 0 1 2. In the second row, we'll get 1 because 1 into 1 will be 1. Now when you will do B or B transpose inverse, this is a 2 cross 2 matrix, so the determinant is 1 by 20 minus 1 and just you change the position and here give the minus sign. So it will become 1 of 19, 2 minus 1 minus 1 10. Now again, uh, the pseudo inverse is B transpose into B of B transpose whole inverse. So this will be equal to 103 1 minus 10 2 minus 1 minus 1 10. So this is like 3 cross 2, this is 2 cross 2. So the matrix will be 3 cross 2. So the final matrix will be 2 minus 1 1 and this will be minus 1 plus 10 9 0 1 minus 10 6 minus 3. So the correct option is from this above. The pseudo inverse is the option B is the correct here. So in this way, we find the pseudo inverse. So now we'll move on to the week 5th, where it was taught about the basics of actuator system. So we'll solve many questions from the week 5. So in the first question, it is asking in robotic application, electric actuators are widely preferred because we all know that the electric actuators are easier to control. So the correct option is option C. These all are just a theoretical question. If you have just listened the lecture, you can easily solve. The next question is the use of gears in robotic arms is preferred in many cases because gear improves our overall efficiency of the drive. No, this is the wrong option. The operating speed required for the arm is likely to be much lesser than the rotational speed of the actuator motor. Yes, it is correct. So whenever actuator motor is rotating, so the speed should not be equal to that. It should be controlled, uh, and it should be little lesser than the rotating motor. And also the operating torque required for an arm is likely to be much larger than the torque generated by the actuating motor. Yes, so this is also the correct option. And this fourth option is wrong, that it can amplify the power generated by the motor. So these are just theoretical questions. Option B and C are correct. So now we'll solve some of the numerical questions. So in the fourth question, it is given that a rectangular coil having length 10 centimeter, width of 5 centimeter. So it is a rectangular coil. So length is 10 centimeter and width is 5 centimeter. It is placed in a uniform magnetic field of flux density 1 Tesla such that the plane of the coil is at angle of 30 degrees. So we know that while finding torque, it is the I cross dl. So the angle between the current and the plane of the coil is 30-degree here. It is given in this question. If the coil has 10 turns and carries a current of 5 ampere, the torque experienced by the coil correct up to 3 decimal place. We have to answer up to 3 decimal place. So we have to find the torque. Torque is given as NB I cross dl. So IL, and here it will become sine theta because into W. So N is equal to number of turns here, that is given in this question as 10. B is equal to magnetic field of flux density. So that is given as 1 Tesla here. I is the current, that is given 5 ampere. And after that, L is equal to length, that is given equal to 10 centimeter. If you convert into meter, it will become 0.01. And after that, theta is equal to 30 degree. And W is the width of the coil, that is equal to 5 centimeter. That is equal to 0.05. Actually, this 10 centimeter will become 0.1. So now we can easily find the answer. So it will become N, that is 10 into 1 into I 5. Length is 0.1. Sine 30 degrees. Sine 30 degrees 1 by 2. And W is 0.05. So this will become 50. That is 5 into 0.05 into 1 by 2, 25 by 2, that is equal to 125 and 3 decimal place. So 0.125 Newton meter is the correct option for this question. Correct answer for this question. So this is just a simple formula based question. So these formulas are taught in the week 5th. You can easily solve this question. So we'll move on to the next question. So in this question, it is given a rectangular coil having length 10 centimeter, width 5 centimeter, and 10 turns is placed in a magnetic field of flux density 1 Tesla. Oh, I think the questions are repeated. No. Okay, okay. This is different question. So the coil sides are perpendicular to the direction of field. Here, theta is 90 degree because the coil sides are perpendicular. So this means sine 90 degree is equal to 1. If the coil is manually rotated at a speed of 1000 rotation per minute, such that the axis of rotation is perpendicular to the direction of the field. Here you can see axis of rotation is perpendicular to the direction of the field. The peak value of EMF developed across the coil is we have to find in the voltage. And we have to find the EMF. So EMF is equal to 2 into number of turns into flux density into length into radius into speed of coil, that is the angular velocity omega. So R is equal to W by 2, that is width by 2 here. So we will write all these terms. N is equal to number of turns, that is equal to 10. B is equal to again flux density, that is equal to 1 Tesla. After that, L is there, that is equal to length, that is equal to 0.1 meter. And after that, R is equal to radius, that is equal to width by 2, that is equal to 0.05 by 2. And then omega is equal to angular velocity, so that is equal to 1000 rotation per minute. So that is equal to 1000 into 2 pi divided by 60. Because in one rotation is equal to 2 pi and 1 minute is equal to 60 seconds. Okay. So this will be radian per second. So now the induced EMF will substitute all this value to get the answer. So in this question, the induced EMF will become 2 into number of turns, that is 10, into B 1, L is 0.1, R is 0.05 by 2 into 1000 into 2 pi by 60. This is omega. So we can do all this. So here we will get 1000, this 1000 will get cancelled. This 2 and this 2 will get cancelled. This 10 will get cancelled with this 3. So it will become 5 by 3 into 5. So that is equal to 5 pi by 3. So the answer will be 5 into 3.14. Let's substitute the value of pi as this. We'll get 5 and then 2103. So something like you will get here 5.233. Okay. So you substitute the value of pi more and then you will get the answer as this 5.233 voltage. So the correct answer for this question is 5.233 voltage. Let me check once whether this session is recording or not. Yeah, it's recording. Most of the students watch it in YouTube. So now we'll move on to the next question. So it is asking in a PMDC motor when the armature is rotated at 1000 rotation per minute, an EMF of 2 volt is developed across its terminal. For this motor, armature current flow required to generate a torque of 0.4 nanometer is. So in this question, it is asking the current. So we all know that torque is equal to Ki, and here K is equal to E by W. So here In this question, the W is how 100 rotation per minute. So this can be written as 100 into 2 pi by 60 radian per second. E is equal to 2 volt. So our K is done. Now torque is equal to 0.4 nanometer, yes, 0.4 Newton meter. So I is equal to torque by K. K is our E by W, so it will E into W. So torque is equal to 0.4 Newton meter into 100 into 2 pi by 60. And EMF induced is 2. So here when you will do into 10, so our answer will be 2 pi by 3. So it will be around 6.28 by 3. So it will be 2.093. So the correct option is given. We have to choose the nearby option. So that is 2 ampere here. That is almost equal to 2.093 ampere. So these questions are just a formula based question. So now we will see some of the theoretical questions from this week, which is asking pick out the correct statements from the following regarding the commutator brush assembly. So we all know that brush are just sliding on the commutator, on the rotator. So like the first option, the commutator and brush rotate together at the same speed as that of rotor. No, it's wrong. They just slide. Brushes slides over the commutator. The commutator segments are insulated from each other. Yes, they'll say it will short circuit when the external power supply is given to the motor. The brushes and commutators are generally made of the same conducting material. No, if it is of same conducting material, then it will short circuit. I think my internet is slow. Oh, now it's so the next is the external supply voltage in the case of motoring operation is applied across the brushes. Yes, the external power supply is applied across the brushes. So option B and D are correct here. So now we'll move on to the next question. So there are last two questions of today's session. So the next question is an electric motor is used for actuating a robotic arm using a pick and place application. It is observed that torque output from the motor has a ripple superimposed over the steady value for a given magnitude of peak to peak ripple. So electric motors used for actuating a robotic arm are used in a pick and place application. So the torque output from the motor has a ripple superimposed. So the ripple can be the torque output is like this. The one output can be like this. One can be like this. And the third is like the amplitude is more and the frequency is less. Okay. So the first option is if the frequency of ripple is higher, the impact of oscillation felt on the mechanical system is likely to be higher. So yes, so whenever the frequency of ripple is higher, the impact of oscillation felt on the mechanical system is likely to be higher. If the frequency of ripple is higher, the impact of oscillation felt on the mechanical system is to be lower. Sorry. Here you can see in this case, the impact of oscillation is Let's suppose this is case 1, case 2, case 3. Impact of oscillation in 2 is less than 3. So here frequency is higher. So the impact of oscillation to be lower. So the option B is correct here. A is wrong. The impact of oscillation felt on the mechanical system is independent of the frequency of ripple and depends only on its finite amplitude. So it depends both on amplitude as well as frequency also. Depends both on amplitude and frequency. So this option is wrong. The movement of the arm always become unstable at frequency of ripple. This is also wrong. So the correct option is option B. I think this question is not recorded, so I will again explain. So in this question, it is asking electric motor is used for actuating a robotic arm is used in a pick and place of application. So there are three cases I have shown in the curve in the graph. Like when there is a frequency of ripple. So in the first case, the frequency of there is no frequency of ripple. In the second case, it is high. In the third case, it is low. But in the third case, amplitude is high. So in the when the amplitude is high, the oscillation is high. When the frequency is high, then the oscillation will be lower. So the option B is the correct option for this question. So the use of gears in robotic arm is preferred in many cases because gear improves overall efficiency of the drive. No, this is wrong. Rotating speed required for the arm is likely to be much lesser than the rotational speed of the actuating motor. Yes, like the speed at which motor is rotated, the operating speed should be lesser than that, and also the torque required is much larger than the torque generated by the actuating motor. Gear can amplify the power generated by the motor and feed the load up. This is wrong. Option B and C are correct. So today we will end the lecture here only. We will meet next in the Tuesday 5 to 7. So all of you can watch this video on YouTube as well. The video will be uploaded and link will be shared. Thank you everyone.